Hey everyone, welcome back. Today we have problem number 131, palindrome partitioning. So given a string called s, partition is such as that every substring of the partition is a palindrome. Return or possible palindrome partitioning of s. So a palindrome is a string that when you read it forward is the same that when you read it backward. So for example, AA is the same as AA. I know it sounds silly, but this is how palindrome works. And yeah, and also each character is one palindrome. If we have two characters, it should be identical. Also, one of the example of the palindrome, if we have a character like A, B, A, for example, because A, B, A from left to right, it will be the same A, B, A from right to left. So this is how palindrome works. So what we should do right now is that we have string and we should return all the palindrome possibilities. And we can do this by basically trying a backtracking function that will try every possible combination and see if it's a palindrome or not. And backtracking is a common technique used to explore different possible solutions. In this case, we will use it to explore all possible ways to split the string into palindromic substrings. The backtrack function, I guess, will take some two arguments to start, which will be the index to start from, and the current position will be an or current partition. Well, I guess will be an array to store the current split. So let's start right into it. So since we're using backtracking, I guess we will need like a backtrack function. Backtrack function, I guess it will take two arguments. One will be the start and the other one will be current partition. And also, I guess we will need, because we will try to loop for each character and know if it's if when we combine it with other characters, will this make a palindrome or not. I guess it will be a good idea to create a helper function to check if a string is a palindrome or not. So is palindrome, I guess it will take three arguments, will be the string itself and left and right. And yeah, we can do it by that. Do we need anything else? I guess yeah, we need to create actually the results array by itself. Result array, which will be an empty array, yeah, I guess we return this one and return this result array. Okay. So let's work on the palindrome function. So I would say maybe we create like a while loop, and it will be like while left is less than right, because always left should be less than right in any array. So if the string of left, string on the index of left equals no. If the string of left doesn't equal string of right, we will return false. So that means it's not a palindrome, because as you can see that a palindrome is a string where when you read it from right to left, it will be the same when you read it from left to right. So we try each combination. So we have like an array called A, B, B, A, for example, something like that. We try and we have the right at the last index and the left in the first. So we try to compare each one of them. So if this equal to this, if this equal to this, etc. So if that wasn't the case, we return false, and left will be plus plus, and right will be minus minus. And if we didn't return anything, I guess we return true, because that means that we have a palindrome. Okay, so next we will have our backtrack function. So the backtrack function is to find all partitions basically. So let's try to, because it's a backtracking function, I guess it will be a function that would call itself over and over and over. And since it's a function that will call itself, it's a recursive function, we need to put some base cases so our function will not run like forever. So one of the things that I'm thinking about, that if we have reached the end of the string, we need like add the current partition to the result. If we reach the end of the string, that means we put all partitions when we reach the end of the string. So I will do that like that. If start equals is.length, that means basically we put result dot push all the current partitions, everything in the current partitions. Okay, and I will return nothing. Okay, so I guess that we can make like a for loop here. I will say let end, yeah, I will call it with end equals start, and maybe end. I could call it s as well, but let's just call it end to make the code more understandable. S dot length should be and end plus plus. Okay. I'll make like if statement again here. I'll say is palindrome to make sure if this string is palindrome, and I'll put the string, and we have left and right, like I would say start and end. So I will put the start, and the end will be our variable that we specified in the for loop. And if it is a palindrome, we will push it to the current partition. So I say current partition, put it like that, dot push, and I will put okay, how we can push on? We need to, like, if the substring is palindrome, we need to add it to the current partition. But we actually was checking the start and the end. So how we can do that? We want to add only the characters that between start and end. So we can do this by dot push, and we will do s.substring start end +1, because I want to take the end as well. And I will call the backtrack function because we were recursive. We recursive to find the next partition. So I will call the backtrack function again. And do this by add end +1. So we have a new start, and we will pass the current partition. And I guess after that, the backtrack we need backtrack by removing the last added substring. Dot pop. Okay, so right now we backtracking, and I guess it's a good idea to call backtrack 0 and empty array. Let's see if this will work. Let's run. Okay, it did work. Okay, so let's try again to talk about the function, how the function works. So first we have the helper function, which is palindrome, and we have the helper function called isPalindrome that checks if a given substring of s is a palindrome. It takes 3 arguments: the string, which is str, also takes left index and the right index. The function uses a loop to compare characters from both ends, left and right, until they meet in the middle. If the characters are not the same, it's returned false. Otherwise it keeps checking until it confirms that the substring is a palindrome. The next thing, we have the backtrack function. The backtracking is basically, backtracking is a common technique, as we said before, used to explore different possible solutions. In this case, we use it to explore all possible ways to split the string into palindromic substrings. The backtrack function takes two arguments: start to which is the index to start from, and current partition, which is an array to store the current split. If start reaches the end of the string, it means we have found a valid way to split the string. So we add a copy of the current partition to the result. After that, we need to we need to talk about exploring the substring. So we iterate over the string, starting from the current start index to the end, which is the end index. This is how we explore the substring. So for each substring, we check if it is a palindrome using isPalindrome function. If it is actually a palindrome, we add it to the current position, and we then recursively call backtrack with the next to start index, which is be end +1, to continue finding more palindrome partitions. And after exploring a partition, we remove the last added substring using a current partition pop. This is called backtracking, and it helps us to try other possible splits by undoing the previous steps. And the result array is to store all possible palindromic partition, and we return it at the end. So we can take an example of how this will work. So let's say that our input s equals like a string which has like a b, for example. The function will find two possible partitions, which will be an array which have a and b, and the second possible partition will be let's put it like that. I guess it will be A and B. So in B, this one, the first one, each character is a palindrome by itself, and in the second one, A is palindrome and B is also a palindrome. So this solution explores all possible ways to split the string, making sure each part is a palindrome before adding it to the current partition. The backtracking technique allows us to explore all combinations and find the correct solution. So let's try to run it right now and see if it works or not. Okay, it will work. Let's submit the code and see how it will perform. Okay, this is not bad because we are at we basically, okay, the memory is beating, but the runtime is not that good. The runtime is it's 29. And there are some people doing. Oh, how did you do that? Let's look at their partition index push. If it's okay. Oh, this solution is, I guess, it's well as well. They're using the same technique, which is backtracking, but they don't have, and also they have a function. But I guess we should take the same time. But yeah, it's 10 milliseconds difference, so I guess it's not a big deal. So yeah, that's it for this video, and I hope you enjoyed it. See you.